Today's video lesson is on page 7 of our chapter 1 notes, section 1.6, which is factoring polynomials. Hopefully you recall this from a previous math course. When factoring polynomials, the first thing you look for is greatest common factor. If I look at the binomial 2x squared minus 4xy, what's common to both these terms? Well, they both have 2 and x in common. So the greatest common factor is 2x. So we have 2x times x minus 2y. The trinomial 4x squared plus 8x minus 12, what's common to all three terms is 4. We factor out 4, and our resulting trinomial is x squared plus 2x minus 3. Now we can't stop there, we have to check. Is the trinomial x squared plus 2x minus 3 factorable? If it is, we need to factor it. The lead coefficient of x squared is 1, so we go to the constant -3. Are there factors of -3 that add to 2? Yes, +3 and -1. So now the trinomial factors into two binomials. X plus 3 times x minus 1. And don't forget to bring over the GCF, the 4. So our resulting completed factorization is 4 times x plus 3 times x minus 1. Next, the trinomial 10x to the third plus 5x squared minus 20x. What's common to all three of these terms? Well, each coefficient is divisible by 5, and each variable x to the third, x squared and x, has an x in common, so 5x is the greatest common factor here. Our other factor, 2x squared plus x minus 4. Again, we cannot stop here, we have to check. Can this trinomial in the parentheses here be factored? Since the lead coefficient of x squared within the parentheses is 2, it's not 1, so we multiply 2 times -4 results in -8, and we need to check, are there factors of -8 that add to +1? No, there aren't. So this is factored completely. Next, we have some special factorizations, factoring the difference of two perfect squares. Again, you've seen this before. 4x squared minus 9, both are perfect squares. The square root of 4x squared is 2x. The square root of 9 is 3. So this factors into 2x plus 3 times 2x minus 3. B, 1 minus 64x squared, each is a perfect square. The square root of 1 is 1, and the square root of 64x squared is 8x. So this factors into 1 plus 8x times 1 minus 8x. Just please be careful. Make sure you don't write it as 8x plus 1 and 8x minus 1, right? Because that would result in 64x squared minus 1. And that's not what we have here. We have 1 minus 64x squared. Next, 200x squared minus 2y squared. Well, they have a greatest common factor, 2. Factor out 2. We have 100x squared minus y squared. And this is the difference of two perfect squares. So it needs to be factored further. 10x plus y and 10x minus y. Our next set is a group of trinomials. The first one, x squared minus 12x plus 27. Again, all of these three, the lead coefficient is of what's called our quadratic term is 1. So we go to the constant. Are there factors of 27 that add to -12, -9, and -3? So this factors into the two binomials, x minus 9 times x minus 3. Next, y squared minus 3y minus 40. Again, the lead coefficient is 1, so we go to our constant negative 40 and look for factors of negative 40 that add to negative 3. And they are negative 8 and positive 5. So this factors into y minus 8 times y plus 5. See the factors of negative 20 that add to positive 8. See, 10 times negative 2 is negative 20, and 10 plus negative 2 is positive 8. So this factors into a plus 10 times a minus 2. And then our last group of trinomials we have where the lead coefficient is not 1. So as we saw from above, we take the coefficient of our x squared term, multiply it by the constant, write down 12, and then look for the factors of 12 that add to 7, and they are 3 and 4. Next, we draw a fraction bar, and we write 2 parentheses for our numerator, and in our denominator we're going to write whatever that lead coefficient was, which in this case was 2. And inside of parentheses of our numerator, each parenthesis starts off with 2, x plus 3, the 3 from here, and then x plus 4. Now, 2 divides evenly into both terms of 2x plus 4. So we divide it in and get 2x plus 3 is just copied. And dividing 2x plus 4 by 2 results in x plus 2. So that's our complete factorization for this trinomial. Now to check it, we could simply FOIL. Right? First term's 2x times x is 2x squared. Outside, 2x times 2 is 4x, plus the inside, 3 times x is 3x, 4x and 3x is 7x, and last term's 3 times 2 is 6. 4x squared minus 12x plus 5. Again, the lead coefficient of x squared is not 1, it's 4. There is no GCF here, so we take and multiply 4 times the constant 5 is 20. And then factor 20. We're looking at for the factors of 20 that add to negative 12. That would be negative 10 and negative 2. Multiplies to be positive 20 and adds to be negative 12. So next we draw a fraction bar. This is a middle step. Whatever coefficient let off our x squared term goes in the denominator, and then starts each parenthesis of our numerator. And finishing out our numerator, it'd be 4x minus 10 and 4x minus 2. Now 4 doesn't divide evenly into both terms of a single parenthesis, so what do we do with this 4 in the denominator? We factor it, we break it down. So we'll express 4 as 2 times 2. And then 2 divides into one parenthesis of the numerator and the other 2 into the other parenthesis, resulting in 2x minus 5 times 2x minus 1. And then our last trinomial, we have 6x squared minus x minus 2. Again, there's no GCF, so lead coefficient here is 6, so we multiply 6 times negative 2 is negative 12. Factors of negative 12 that add to negative 1 are negative 4 and 3. We draw a fraction bar. 6 goes in the denominator, and then our numerator consists of 6x minus 4 times 6x plus 3. 6 doesn't divide evenly into one set of parentheses, so we break 6 down and write it as 2 times 3. And 2 will divide evenly into the 6x minus 4, and 3 into the 6x plus 3, resulting in 3x minus 2 times 2x plus 1. So just review these one last time. Remember, first thing, always look for a greatest common factor. Then see, do you have just two terms? Are they the difference of two perfect squares? And remember, it must be subtraction. And then if you have a trinomial, if the lead coefficient is 1, you go right to the constant and look for those factors. If not, if the lead coefficient is not 1, that's when you have to do what's called this factor in, factor out method. This concludes our lesson for today.